So customer had us make this part, and then they had us make this assembly, but they never told us these two parts go together. They had an issue with their tolerancing, so this piece doesn't fit in here the correct way. They tried and got it stuck, so stainless on stainless will gall up very easily. So that's what you're seeing right there. So luckily, we got this out, but we're probably gonna have to remake this and clean up that part and salvage it. So had we engineered it, probably wouldn't have been a problem. Well, get them out with enough cussing.
I heard some hammering over there, yeah.
When in doubt. So
okay.
The one that I pressed in came right out. I barely hit it with the press, and it, it like popped. I was like, oh, that makes me nervous. So I stopped. The one that was barely in there was this one, or one of those other ones. But we don't have to go all the way. You can hold 1 1/8 inch.
Okay.
And then just.
You need it now?
About a while.
Okay.
Something like that. All right. Weld's hot, right? So you're putting all the hot metal. The metal's gonna expand because hot things expand, right? But then it's always gonna shrink more than it expanded to a point. So if you have a hole that's exactly 1 inch, 1.0000, you do all this welding around it, that hole is going to be less than 1. So if you've got a pin that's only 1,000 smaller, after welding it ain't going to fit. So that's what they tried to press it in there. With stainless on stainless, it's not going to work.
So best case scenario, we cut it, it fits, and then we send it back?
Yeah, so we're going to take about 1/1000th out of that pin, and then just check fit so we have a slip fit, so it goes in and out of that hole nice and easy. Yeah, so you can see just snapping that down. Did you hit it?
I didn't hit it. I got it.
Okay, so what happens? So this piece right here gets machined down, gets bored out to within. They wanted it. Let's see. -0 plus 1 thou, but then we weld all the way around it. We weld this to that, so it's going to shrink up. This pin's supposed to be +0 minus 1 thou, meaning if we were on they would clash potentially, or we might end up with a 2 thou clearance. But after welding, this pin doesn't get welding, so it's exactly 1 thou under. But this hole is not. It kind of leads you to believe you could press it in there, but it's not a slip fit. And with stainless, you don't want to gall it up. So this pin actually goes down into the bore, and there's a little bolt through this side piece here that will thread into here. So we didn't know any of that when we made it. Customer had to make this. We made this full assembly here. They got ambitious and tried to press these in, and you can see what happens. So they get like super galled up. So we're lucky to literally get these pieces out, because that's basically metal sticking to metal. So what we're gonna do is take it. There's not much we could do here without a pretty elaborate setup in the mill. So we're just gonna turn this pin down to clean off this galling about 1,000. And it'll have a little bit of a shoulder on it, but it's sticked up, so you won't even notice that. Turn on the lathe and get it to work.
Before we go about turning these down, we need to figure out where we are here and where we are here. So I'll get a set of calibrated calipers. We'll figure out where we are so we know how much we have to go, and then we'll go over to the lathe. This hole here with like a plug gauge, but we don't have any this big. So the biggest reading I got was 9985, and over here we're 9995. At their closest measurements, there's 0 tolerance or 0 clearance, and at the smallest measurement on the bore and the largest measurement on the pin, there's at least 1 thou, maybe more of a press fit, which is not what we want. So we'll turn these down. Really, I just need to know how small it's past the tape.
Okay.
Because in theory, before welding, they were right on. The hole was 999, the pin was 999 thousandths. So just 1,000th under 1 inch. But now we've welded, so the bore is a little small, and since some of these were pressed in, there's kind of an imperfect surface there. Part of it's pressed in, part of it's mushroomed out. So I'm trying to figure out what the lightest pass I need to take to bring the diameter of this into basically 1/1000th of an inch under the dimension here, so that it'll just slip right in and then stop at the shoulder that I create. We know that we need to make 2 of these pins if we're going to do like a thou slip fit. We need to take this pin down 1 thou, so that would be a 1/2 thou off of the radius, which would be 1 thou off the diameter, to get this pin to be a slip fit with that bore there. And each of these is going to be different. So the setup I have now is much simpler than the one I initially was going to do. I think I was pretending that this machine and myself had a lot more capability than it did, but I couldn't get this thing to consistently take good surface finish 1/2 thou passes. So I went with a much simpler setup, which is I'm going to file these ridges that were created from galling off, and then just take the sandpaper, use the good old guess and check method. Not quite, we'll measure it and make sure it's going to fit, make sure we don't go too far, but this way I don't have to worry about concentricity or setting too much setup. Not very elegant, but it should work. So here I'm just taking light passes over the area that was galled, see if I can knock down those high spots. And before I did this, you can already see, but I had this flipped around in the lathe, put some blue dicom on there for layout, and then while it was turned around, just made a little line of exactly where that's supposed to sit on the mating part. So I have a little line, as you can see, of where I'm going to be sanding up to, and shouldn't go past. Alright, we've mostly knocked off the high spots, so I'm just going to do a sanity check, make sure it doesn't just fit already. Yeah, that's not going to go in. We still got some high spots in there that we can't do a whole lot about, and then I'll just bring this down for a bit. Move on to the sandpaper. Getting pretty close. This isn't something you would want to just chuck up in your lathe and then start sanding on. You can see I've protected the ways, because this fine grit is not something that you want to get in between the ways and the carriage.
And that's what that sheet here is for?
Yeah, that's what I have the cloth over the ways for, so that all this fine powder basically that's coming off this part doesn't act as its own sandpaper between the ways and the carriage. So at the very least, we've cleaned up the high spots on this one. I hit the file a lot more down here than I did up here, so it goes in about halfway. I'll just keep sanding up here. Don't want to take too much off on the bottom where it already fits, so I just folded the sandpaper over so we're just hitting the problem spots. I'm gonna call that one done. Now just 3 more to go. But it's a little tedious, but at least we know it works. And with the other method, we were running into a skill issue, so. That ought to do it.
So what would our next step from here be?
Now from here, we'll wipe them down with acetone. I already got all the acetone off, or all the layout fluid off the pins themselves, but wipe them down, deburr, ship it back to the customer.
Very nice.